Chapter. Let me first introduce myself. So I am OCaml hacker. I started learning functional programming using OCaml like more than 10, 15 years ago, I don't know. And writing my master thesis and PhD using OCaml, and working in Lexify and Gen Street a bit, a few years for each. And now, but still I stopped using OCaml in my work. I jumped into Haskell industry 3 years ago. But I don't still, as I wear my t-shirt, I don't still lose my love to OCaml. Well, both languages are, well, to me, they have both unique charms. So yeah, I use Haskell in my work, but at home I use OCaml usually. Okay, so. Haskell is a bit different from OCaml, that they have type classes, purity, and laziness. But for these 3 years, I managed to work standard chartered and writing Haskell code without being fired so far. So, but actually, these things didn't really help me to work there. What really helped me there is Fugu. Fugu is an API search engine for Haskell by Neil Mitchell. What's an API search engine? So you can find library functions or types or many things by, for example, by name. If you give concat, then if we would have such kind of search engine in OCaml, if we give concat, then it answers. There are list concat, array concat, and string concat, and so on. So if we give a type of monad bind, then it should done binding operators or concat map. Or even you can give the both. So if you can find a function of name search, which takes a regex expression as an argument, then it should find a regex search of this type. And this kind of things are theoretically, it's pretty old thing, maybe from 80s, I think. So, in standard charter, I use Fugu more than 30 times a day. Especially for each time I use fold L in Haskell, I have to use Fugu since due to its bizarre order of arguments, It has completely different order from our, OCaml's list of all left. So it should be pretty useful in OCaml too. But as far as I know, there's not so many equivalent so far. So I built OCaml. I built my own Fugu for OCaml called OCamlOScope. So for example, for concat. It searches and lists the concat functions for list, arrays, strings, and so on. And for monad bind, yes, it finds binding operators, bind and concat map to use what it is. And for words, So for this type name, it finds a function of name search inside JS of OCaml. Okay. There are some previous implementations of API search in OCaml too, but they are a bit less powerful. And maybe I have no time to tell all the details, but so just running through. So there's an OCaml browser available in label TK graphic GUI library, which performs API search, but it's limited basically locally. So you only can search things in your hard drive, and it uses OCaml type system, and it's okay, but it's too OCaml. So it has the same program like OCaml. So if you have two module names, the two modules with the same module name, then one can hide the another, or something like that. Okay, and there's remote API search servers there was called OCaml API Search, and it provided search capability for standard library, other libraries, and exploit. But it's based also on the OCaml browser code using CamL GI, so it has the same characteristics and limitations. And unfortunately, it's already discontinued. So, and this why we couldn't have such API search for a long time, since I think it seems we didn't have enough tools. So we had CMI files. Well, it contains some type information of modules, but it's less informative for API search. No locations, no documentations inside. And so we can extract some information from the source files, but we need precise compiler options. Otherwise, we cannot even compile. We cannot even parse the source file. So, for example, this stat.ml requires these kind of options. Otherwise, it cannot be even parsed by OCaml compiler. And these things are even more complicated, since OCaml doesn't like to have only one installation mechanism. So we can have configure, make many build systems, and API search engine, API search scraper cannot really handle all of them. But these situations are recently changed thanks to this CMTI files of OCaml. So it contains compiled AST with locations. It doesn't contain documentation, but it has some the precise information to how to compile, how these files are compiled. So we can get the compilation option from these CMT files and run OCaml doc with these options. Okay, and even more, OPAM packaging system provides a wrapper to unified installation scheme. And also compiler libs expose us OCaml compiler internals, which makes us pretty easy to write these kind of things. Okay. So I wrote OCamlOScope for OCaml, well, mostly. So it is remote search, it's not local, so you can find there probably interesting libraries using OCamlOScope, which is not yet installed in your system. And it uses edit distance-based search, and the database is completely on for efficiency. So for example, so search by edit distance. So for example, we can here find it by this American finalize. Using this American finalize, we can find this GC finalize function. Yeah, this one. Thanks to edit distance search. Yeah, it contains OCaml documentation, but not quite pretty yet. Okay. And same for, so this is for names. And same for types. We can also have a search, edit distance-based search for types. So concat, so we want to find a function concat of this type and find, for example, this one, which shares the same type here, but the extra argument. Okay, something like that. So pretty useful. So even if you don't know the exact type or exact name of your what you want to find, OCamlOScope somehow helps you. And there's a performance. So far, it runs in my small cheap VPS, and well, every search, as far as I tested, it finishes in in 3 seconds. So I think it's pretty usable. So the database is, well, something like this. I have just blindly installed more than 100 OCaml packages from the top priority to the bottom. It consists of 185 OCaml find packages. And it contains more than 500K entries, values, types, constructors, classes, modules, and so on. And the full data, final data size is 39 megabytes in a disk, which is expanded to 170 megabytes in memory. And actually, this is about half size if I compared to the memory size. If I have had to load all the CMI files blindly to memory. But well, OCamlOScope is like full, but it has own challenges. So for example, scraping. Scraping, we have in OCaml we have 2 package systems. One is OPAM for installation, another is OCaml find for linking. So for scrapers uses OPAM packages. OPAM package build directories to scan files and scan source files and CMD files to get the database. And after that, module hierarchy. So OCaml has no clear module hierarchy like Haskell. So I use OCaml find package names at the top level module names to make things more clear. And after that, I had to write some small code to find out the relationships these 2 packages involve. So which OPAM package provides which OCaml find packages. So you can see something like this. Now, left side is OCaml find, the right hand side is OPAM packages. So yeah, basically they have all the same names, but sometimes OCamlNet provides lots of OCaml find packages. So sometimes this information is useful. Okay. Sorry. So only 2 minutes. Okay, I have to put this. So yeah, another glitch is too many search results. OCaml has a bit strange behavior and characteristics. So if I search plus, then it returns 260 results. If I give type of bind, it returns 500 results. And for map, 5,000. For example, if I click map, then it lists all the maps, modules, from core, still core. Finally we can see some classes named map, and still not yet. No. And finally we see some other map familiar functions. So it's really hard to translate. So I had to work around this. So this is because due to in OCaml we can pretty easily dupe things using module aliases and module inclusion. And in OCaml we have no type classes, so many names are scattered around many modules. So so far I have introduced a workaround to group the search result into short names. For example, this LW bind function has short name like this, and this result is grouped together with other result with the same name. So for this works pretty fine. 500 results becomes 8 groups, 260 becomes 30 groups, and so on. So for example, for bind, so we have more than 300 results here, but grouped into 5. Well, of course, it contains too many things inside, but still, it's pretty nice. So, well, for future work, maybe I have to push these things more, and introduce real alias analysis between values, and only displays the original, but still not to be done. This is not yet done. This must be done. Yeah, so many things. I have just started this work last year. It's I am not working on OCaml in the office, so just a hobby program. So there's so many things still to do. Okay, that's it. Yep.
Just thought about how this is going. Other thing about it is well, you want to have somebody like copies of market data. Another thought is you might be able to use the signature structure. So we don't have 10 classes where you have this kind of compositional construction interface.
Yeah.
And so a lot of those maps in core
mappable.
From various kinds of all the iterators for example come from pretty much a container interface. All the to and from SQL So in some sense, things that come from the same interface that naturally put together.
Yeah. So somehow we regain some type plus style information from that.
So the intent of things is a unified API is made explicit by the
Yeah.
So do you plan to have some integration with editors?
Oh, not yet, but of course, surely it's possible. Yeah. Yes.
Thanks a lot for doing this talk. And just a little question in OCaml, if another way of structuring data, which is modules, for example, is it possible, or are you going to implement a solution that allows me to ask for, please find me a module signature that contains this and that other functionality together?
Oh, yeah. I considered about this, but not implemented, since it's a bit complicated to write that query language.
Well, as you know, I mean, the theory is pretty old and it's already worked out, but it's a lot more to implement it.
Yes?
You may have noticed this did you mean blah feature of some of the recent OCaml releases. And I see that you are doing edit distance based search. So do you have any suggestions for this feature that came up during your work and looking at libraries and so on?
I'm sorry.
I mean, did this give you any idea of what kind of suggestion you may make when people have errors with an identifier that is not found?
Oh, I don't know. For example, OCaml compiler itself are there. Such kind of things. Maybe we can combine these things into one. I'm not sure. I can work with that. So anyway, so this project just started, and I'm not full-time OCaml programmer, so I ask your help if you want. Thank you.